Are we? So for this video, we are solving a couple of problems. And here for number one, you have t there being square root of x plus 5 minus x over x minus 1, where x could be any of those numbers in the curly brackets. So choose, now they say choose from a given set of numbers the value of x for which t will be irrational. Right, so for it to be irrational, we must be able to write it in a form of a over b, where both a and b are integers, right? Cool stuff. So if we pick minus 6 for rational, minus 6, you're gonna have minus 6 plus 5, which is minus 1, and this not a real number, right? So we move from minus 6, we go to minus 2. What about minus 2? We have minus 2 plus 5 equals to 3. But then square root of 3 is not a real number. It is a real number. What I'm trying to say is square root of 3 is not rational, right? So when you have this, remember now you have minus 2 minus 1. It's going to be square root of 3 over minus 3. That number is not, because this is not an integer. This it is, this is not. But remember, so we say we must be able to write it in a form of a and b, where both a and b are integers and b is a non-zero, right? So minus 2, it doesn't work for us. Yeah. What about 1? Right, so 1, you have 1 plus 5, which is 6, and then square root of 6, it doesn't also work for us, right? Because square root of 6, you have square root of 2 times 3. We have square root of 2 times square root of 3. Both of these are irrational. So it doesn't even work, because now this, of course, this is the first thing, it's irrational. But then for your denominator, you have 1 minus 1, which is 0. Denominator cannot be 0. So all of these numbers, they don't work, right? Let's test the last one, which is 4. Already you see 4 plus 5, which is 9, and square root of 9 equals to 3. So then you have also for your denominators, you have x minus 1. We can say 4 minus 1, which is 3, right? So you're gonna have 3 over 3. So 4 works. So you can say here the answer, it'll be 4, or you could say x be 4, right? Oh, let me just write this, x is equals to 4, right? And then for non-real, I think we did talk about it. There are two cases. One is here where we get minus 6, square root of minus 6 plus 5 being square root of minus 1. This is a non-real, so we'll say x equals to 6, right? Yeah. And then another one, it was with 1, where in the denominator you had x minus 1. So if you substitute 1, then it's 1 minus 1, which is 0. And we can't have anything divided by 0, it doesn't work. So you also have x equals to 1, right? We're done. Let's move on to the next question. Beautiful. We are factorizing here, né? So for the first one, like I said, guys, when we are factorizing, what's the first thing we want to do? Highest common factor. Do we have it? Yes, we do. In this case, we have x as a highest common factor, so it's 3, right? And then you are done, just like that, my friend. You are done. We go to number 2. Number 2 is a grouping. You have y, you have x. You can decide to go with that group, or you could do it otherwise, but let's go with that grouping. So it's gonna be y minus xy is your first group, plus x minus 1, right? And therefore you're gonna have y as a common factor, so you have 1 this side, minus x plus 1 into x minus 1, right? Or let's instead take out minus 1 as a highest common factor, and therefore you're gonna have 1 minus x if we take out minus 1. So you have a highest common factor, which is 1 minus x, right? and then you have y minus 1, right? You are done factorizing. It's done. Another way, just to for those who use the different grouping, you could say you have y minus 1 plus x minus xy, right? You already see the idea here. You already see the idea here. So we factorize here. We're just gonna have 1 plus, let's take out actually minus x here, minus x, so that we have y minus 1, right? Yes. Highest common factor y minus 1, and then we are left with 1 minus x, which is exactly what we have here. So yeah, just in case someone uses a different group, right? This one, we have this guy over here, and we are simplifying. It's 2 marks. I think this is enough to give you a clue, right? And the reason that it's 2 marks is because, look, we have done it. Ne? We have done it. We know what this is, and I will show you. You have a binomial, ne? And then with this binomial, you have x squared. Then here, it's a positive. Then here, all of a sudden, you have a negative. It's a negative, but you had a positive, and then it's these two multiplied together and this one squared. You know the answer, of course, is going to be x to the power of 3 plus 3 to the power of 3, which you can say is x to the power of 3 minus plus 27, right? If you don't know this rule, you're going to do it the longest way, multiplying everything all out, but eventually you will get to this number over here. So something really cool. Let's move on, friends. Determine the numerical value if I just realized something now when I was putting on this question. So this one, I think it's under equations and inequalities, right? So yeah, we will do it then. Bad. But I can do it. I will do it with you guys. But I just want to say that this one is not for chapter 1, but we will do it together. So we have a number there, 1.3.2. That number we're just trying to simplify it. Right, we're trying to simplify it. So the first thing first, let's check, can we factorize it? Yes, we can. How? We have a highest common factor, which is what? Which is x. So we take out x. You have x squared plus x plus 1, right? Can we factorize our denominators? Yes. So how do we do that? You have x minus 1. You have x plus it's going to be just x plus 1, right? Oh, this is x squared. Yeah, this is x squared. And then you have plus, you have x into x plus 1, right? And then here, difference of 2 squares, you have 1 minus x, right? 1 plus x, right? Cool. And then we go again, x plus 1. And then here, difference of 2 squares also, x plus 1, right? X minus 1, right? So now numbers are going to cancel out. This divides this, this divides this, this divides this, right? I'm just going to leave a couple of ones there for the division. So that means here you have x over x minus 1, and then plus here you have 2 over 1 minus x, right? And then here you have just 1 over x minus 1, right? So just want to make you aware that our denominators, they are the same. We will do just a slight change. So you have x over x minus 1, right? And then plus, right, then 2 over minus 1 x minus 1, right? And then plus 1 over x minus 1, right? Perhaps I can add these two together since they just look exactly the same for now. So therefore I have x plus 1 over x minus 1. So then this minus and this positive, minus 2 over x minus 1. So now with the denominators being the same, you have x minus 2 minus 1 over x minus 1, which is 1, right? Maybe I was too fast. You have x plus 1 minus 2 over x minus 1, which is x minus 1 over x minus 1, which is 1. All right, long, but yeah, we got it. Cool stuff. So this one, like I said, it's not in the chapter we were doing, but I'll just do it if you might be interested. If you're not, just skip to the skip to the next part. So here, determine the numerical value of this guy if it is given that this is 12. And right, so we look at this number, right? When you look at that number, you have what do you have there? You have 9, you have 9x squared plus y squared equals to 12, right? So we're looking for the numerical value of this now. So I'm thinking let's expand it first. 3x plus y. If we expand this now, we're gonna have 9 squared. There's a method that I taught you guys which is very simple, very easy, straightforward. You square these two, you have 9x squared. You multiply them together and then multiply by 2. So you have 3xy multiplied by 2, that is 6, plus 6xy, right? Then you have plus yx squared, right? Then you have 9x squared plus 9 plus y squared. Then let me say plus 6 into xy, right? So here, this is where I'm doing the substitution. They said that this is 12, so here I'm gonna have 12 plus 6. They say xy is minus 3, so I have minus 3. That means I have 12 minus 18, which is minus 6. Yeah, let's move on, friends. So there we have something beautiful. I want to show you now. So this guy over here, we can write him as x to the power of 2 times 2. All right, well, let me just do it this way, right? Squared, yeah? Minus 9 squared, right? Cool. Just step by step. I hope this is very clear, because we raise power to power, we multiply the exponents. We're gonna talk about laws of exponents in the next chapter, right? Here I could also write it as 3 squared, but don't want to make it messy. But if I want it to look like this, I could say 3 squared, right? Then they kind of look the same, right? Perhaps let me continue with this one. Yeah, but difference of 2 squares, so I'm focusing on my brackets. So I'm gonna have x squared minus 3 squared, right? And then I'm gonna have x squared plus 3 squared, right? Here I have difference of 2 squares, so I'm gonna have x minus 3. I'm gonna have x plus 3. Then I'm gonna have this guy, I can't factorize him much further, so it's gonna be x squared plus 9, right? And yeah, the factorization is done, and look, it's even 2 marks, right? So yeah, we simplifying this expression. Yeah, it's very cool. Let's do that. Before, maybe I just I want to factorize this. I can with the numbers for -4 and 3, right? +3. So I have 3 over a minus 4 plus 2 over a plus 3 minus 21 over, this is now my first bracket, a minus 4 into a plus 3, right? This is exactly what I have after factorizing this, man. And then here I'm already seeing that my basis. So here I can use that method that I was showing you of multiplying fractions. No, adding fractions, right? So of course we'll have minus, we have 21, a minus 4, a plus 3, right? So now I'm gonna have a minus 4, I'm gonna have a plus 3, right? Once I'm done, I have 3 into a plus 3, right? Then I have plus 2 into a minus 4, right? So my denominators, they match. I can just say I have 3a plus 9 plus 2a minus 8 minus 21. Then I have a minus 4, I have a plus 3, I have 5a, and then it's gonna be okay, let me take 1 from here and put it there. Then I have minus 20, and I have 8 minus 8, that is 0, so minus 20, right? And then I have a minus 4, I have a plus 3, right? Then I have 5 into a minus 4, I have a minus 4, a plus 3, they cancel. Then I have 5 over a plus 3. Right, what I want to check is just the additions here. I'm not using a calculator, so I just want to recheck. 9 minus 8 is 1, so 1 plus minus 21, it is 20. So yeah, let's move on. Cool stuff. I think this is the last set of questions. It is so let's do 1.3. They say determine without using a calculator which two consecutive integers does that lies in. So you have 51. Let's start there, right? We're gonna of course put on two values here, and in terms of our values, we're thinking also about the square roots now. I'm thinking 51. After 51 we have 64, so I'm gonna put 64 here, and then we have 49 as well. I think we did this example, we did this problem when I was teaching the content. So when you have square root of 49, square root of 51, square root of 64, you therefore have 7, 51, 8, and therefore you've answered the question to say the answer here it's 7, and or you could just say between 7 and 8. Done. Cool stuff. So 1.4, they are saying prove that that number over there 0.245. I'll put a line. I love it that way. Then they say prove that this number is a rational. Basically, what is a rational number? It's a number that we can write in a form of a over b, such that a and b are both integers, and then b is a non-zero, right? And here you have a decimal which is repeating. It's a multiple of 3 numbers, or a pattern of three numbers repeating themselves after the comma. Alright, so you know the first step, we're gonna say let x be 0.245 right, and then now I'm going to multiply. As for which number will I multiply by, remember I want to make sure that the numbers after the comma are the same, right? I don't care about the numbers before, but the numbers after the comma, they have to be the same. Okay, let me say this is equation 1. So 1, 2, 3, then everything is the same, so I'll multiply by 100. No, not 100, by 1000. So I'll have 1000 x and 245 1 2 3 comma 245 245 Now everything after the comma is the same between these two equations. This is equation 2. Now we go again and we say equation 2 minus equation 1, right? That is 1000 x equals to 245 245 245 minus x equals to 0.245 245 right. Once we have done this minus this, it's gonna be 999x equals to, we're gonna have 245 minus 0, that is 245, and then 0.245 minus 0.245 is just 0. Then now we simplify, right? So you have 999x equals to 245, right? We simplify, divide by 999, right? So therefore x equals to 245 over 999. You have done it, you have solved it, and you have proved that it is irrational. But you know, sometimes your mind is just your mind sometimes can messes with you up, and you would wonder, wait, I wonder if I actually got it right. So let's just press the calculator to confirm. Yeah, this time around I made the calculator big. But yeah, 245 divided by 999. Right, we look at the answer, 0.245 245 245 245. Right, so you see that these numbers, they're a repetition. Right, so we did prove it is a rational number. We are happy. We have 100 over 100, and yeah, let's go to grade 11. Okay guys, I'll see you in the next video.